Hello students, today we begin a new series on SAT ACT Advanced. This would feature advanced questions from different topics on these two exams. Today we'll discuss percentages. If you're not sure of the basics of this concept, learn the basics first and then come back and attempt this drill. Question 1. The radius of a circle is increased so that its circumference increases by 5%. The area of the circle will increase in percentage by what? So we know that the circumference of a circle is 2 pi r and the area is pi r squared, where r is the radius of the circle. So we see that the circumference is directly proportional to the radius. So if the circumference increases by 5%, the radius would also increase by 5%, right? Which means that my new radius is 1.05 times my old radius, right? Because an increase of 5% means it's multiplied by 1.05. So what would happen to the area? The area is proportional to r squared, which means that the new area would be 1.05 times, as in 1.05 squared, the original area. And what is 1.05 to squared? Let's plug that in the calculator. That comes to 1.05 multiplied by, that is 1.1025. So that's 1.1025 times the original area. Now, if the new area is 1.1025 times the original area, that indicates that the original area increased by 10.25%, right? We need to look at this part, and that is an increase of 10.25%, option B. Okay, question 2. An item in a store is originally priced at $4. A clerk marks the item up by 100%. After that, a second clerk marks the new price up by 200%. What was the final price in dollars after the two markups? Okay, so the original price was $4 and the first clerk marked it up by 100%. So the new price becomes 4 plus 100% of 4, which is 4 plus 4, and that's 8, right? And then the second new price is the 200% markup of 8, right? So that is 8 plus 200% of 8, which is 8 plus 2 into 8, which is 8 plus 16, and that's 24. So the final price after the two markups would be $24. Number 3, if John makes a contribution to a charity-funded school, the average contribution size will increase by 50%, reaching $75 per person. If there were 5 other contributions made before John's, what is the size of his donation? Okay, so let's say we have before John came into the picture and after John came into the picture, right? And let's say the average before he came into the picture was X and after it is $75, right? So X was increased by 50% to reach 75, which means 1.5X is 75. So X is 75 by 1.5, which is 50. So the average contribution before John donated was $50. Now, the number of people before John came was 5. There were 5 other people. And here, once John contributed, the number of people becomes 6, 5 plus 1. So what is the total contribution before John? That will be average times number of people. So that's 50 into 5. So that's 250. And the total contribution with John included would be average times number of people. So that's 75 times 6, which is 1450, right? So what would John's contribution be? It would be the difference of this and this, because this was before John and this is after John. So John's contribution will be $200. Okay, let's go to the next question. The following table shows the amount of rain that fell during a 15-day period in 2008. If 200 inches of rainfall was expected to fall during all of 2008, what percent of the expected yearly rainfall was reached during this 15-day period? Okay, so let's first find the total amount of rainfall that fell during these 15 days. So this is the rainfall in inches and this is the number of days. So there was zero rainfall for 6 days, so that total is 0. 1 into 4 is 4, 2 into 3 is 6, 3 into 1, 3, and 4 into 1 is 4. So the total rainfall for these 15 days is 6 and 4, so that's 17, right? And 200 was supposed to fall during all of 2008. So what percentage was reached during this 15 days? That's 17 by 200 into 100, which is 8.5%. Option D. Okay. Question 5. How many ounces of pure water must be added to 30 ounces of a 30% solution of acid to yield a solution that is 20% acid? Okay, so let's say that this is a 30% solution of acid, right? And this is 30 ounces. And then I add water into this. Let's say I add X ounces of water. So I get how many ounces of the liquid? It will be 30 plus X, right? Because there was 30 ounces originally and I added X ounces of water. So now the total volume is 30 plus X ounces. And I need to have 20% acid, right? So the idea that I can use is that the amount of acid in both the solutions, before and after adding water, the amount of acid has not changed, right? Because it's only water that was added. So how much acid here is here? The amount of acid is 30% of 30 ounces, right? So 30% of 30 ounces, and that should be equal to 20% of 30 plus X, right? Because in this 30 plus X, 20% needs to be acid. So these two have to be equal. So 30% of 30 is just 9, and 20% is 0.2 times 30 plus X, which is 6 plus 0.2X. So 0.2X is 3. So X is 3 by 0.2, which is 15. So I need to add 15 ounces of water to the solution to get the desired result. Okay, number 6. 100 students at Century High School participated in the math test last year, and their mean score was 100. Okay, so there was 100 students, and their mean score was 100. Okay. The number of non-seniors taking the test was 50% more than the number of seniors. So let's say the seniors is X, then non-seniors is 1.5X, right? Because the number of non-seniors was 50% more than the number of seniors. And the mean score of the seniors was 50% higher than that of non-seniors. Okay, so let's say the mean of non-seniors is Y. So mean of seniors is 1.5Y, right? What was the mean score of the seniors? Okay, so first we can find the number of seniors and non-seniors because we know that the total is 100 students. So X plus 1.5X is 100. So 2.5X is 100. So X is 100 by 2.5, which is 40. So there are 40 seniors and 60 non-seniors, right? Now, how do we utilize the concept of the mean? We know that let me first clear this. We know that all 100 students have gotten an average of 100, a mean of 100, right? And we know that the average for the seniors is y and the average for the non-seniors is 1.5y. So if I take the average of the seniors and multiply it with the number of seniors, 40y, and if I take the average of the, oh sorry, this was seniors and non-seniors, so I multiplied the wrong elements. Okay, so I need to multiply 60 with y, 60y, and I add that to 1.5y into 40, then this is the total score of all students, right? Because I've taken the senior number, multiplied it to the mean of seniors. I've taken the non-senior number of students, multiplied it to the mean of non-seniors, and I've added them. So this total score of students should just be 100 into 100, because I know that the mean for all 100 students is 100, right? So now I have an equation in y. So I get 60y plus 60y is 100 into 100. So 120y is 100 into 100. So y is 100 into 100 by 120, right? So do we need that? Do we need y? We need the mean score of seniors, which is 1.5y. So let me just write it on top. We need the mean score of seniors. Mean score of seniors is 1.5y, which is 1.5 times 100 into 100 divided by 120. The zeros cancel. I can take out this 0 and remove this. So 3 5s are 15, 3 4s are 12, 25. 25 into 5 is 125. So the mean score of seniors is 125, right? Okay, so that was, as I said, an advanced drill. So if you had some trouble with it, it's important to go back and revise percentage concepts. This drill is basically targeted at those who are looking at a 750 plus in math. I'll have more such advanced drills for math coming up in future. So make sure you subscribe to the channel and hit the like button if you like this. I'll see you guys in a new video soon. Take care. Bye-bye.